All right, in this video, we are going to look at complex rational expressions. Um, Complex fractions are fractions where the numerator and or denominator contain fractions. And up here in this paragraph, it talks about how we're going to simplify these. We're first going to find the least common denominator of all fractions appearing within the complex fraction. And then we're going to multiply both the numerator and the denominator by the LCD, or the least common denominator. So let's just jump in and take a look. Our denominators in number 1, we have one denominator of x and one denominator of x squared. So the least common denominator would be x squared. Just kind of think, if we were going to try to make these denominators the same, what would we choose? And we choose x squared. So I'm going to multiply both the numerator and the denominator by x squared, the least common denominator. And when you multiply both the numerator and the denominator of a fraction by the same thing, you're essentially just multiplying by the number 1. X squared over x squared is just 1. So we're not changing the value of this. It's what we're going to get is equivalent to this original expression. So I'm going to show a bunch of work. Maybe you wouldn't need to show this many steps if you were doing this problem on your own. But I'm going to show that I'm multiplying the numerator by x squared, and I'm multiplying the denominator by x squared. Now, when I multiply the numerator by x squared, I do need to distribute this x squared. So both the 5 and the 2 over x get multiplied times x squared. This is going to give me 5x squared plus, here, let me show real quick. Okay, so what I'm doing is I'm distributing here. Same thing, I'm going to distribute down here as well. I'll just kind of show that there. Sorry about that, the update. Okay, so I have 5x squared plus, turn that back to blue. Okay, so I'm going to take x squared times 2 over x. This is going to become 2x. Okay, let me show my work. I'm going to show my work up here. So I'm taking x squared, I'm going to call it x squared over 1, and I'm multiplying by 2 over x. Okay, I could also write it as I'm going to take x squared, which is x times x, over 1, and multiply it by 2 over x. So hopefully you can see here that one of the x's in x squared would cancel with the x in the denominator, and that's where I'm getting this 2x. So I have an x and a 2 left. Okay, then in the denominator, x squared times 25 is 25x squared, and then it's just going to be minus 4. Kind of about the same thing here. If I'm going to take x squared, and I'll show it down here, if I'm going to take x squared over 1, and I'm going to multiply it times 4 over x squared, I can see that I'll be able to cross cancel these x squareds, and I'm just going to have minus 4. Okay, so we have 5x squared plus 2x all over 25x squared minus 4. Let's look up here. It does say, finally, we will factor and reduce when possible. So this actually, this is a good answer, but it's not the best answer because it is not reduced. So we're going to want to factor and reduce this answer. 5x squared plus 2x, the only way we can factor that is to pull out a GCF of x. So I'm going to pull that out, and I'm left with the expression 5x plus 2. In the denominator, I have a difference of squares. It will factor as 5x minus 2 times the quantity 5x plus 2. All right, somebody is at my door if you heard that doorbell. Sorry about that. It's probably just a package or something. And then I see that I do have a common factor of 5x plus 2 in the numerator and the denominator. So I'm going to cancel that. And my final answer for this problem will be, I have an x in the numerator and a 5x minus 2 in the denominator. So this is the best, most reduced answer for this problem. Okay, let's look at another one. Next one here we have 2 over x plus 5. That's our numerator. And then 6x over x squared minus 25. Now the process that we used in number 1 can be used again, where we take the two denominators and we multiply by their LCD. Now the first denominator, or this one here, is x plus 5. This denominator, it will factor as x plus 5 times the quantity x minus 5. So our LCD for these two denominators would be x plus 5 times the quantity x minus 5. And you could multiply both the numerator and the denominator by that LCD and simplify. Okay, but I would actually do something different for this one. And the reason why I would do something different is because we just have a single fraction in the numerator and a single fraction in the denominator. We don't have a sum or a difference. I mean, we do like within the denominators. But in my opinion, the best way, the easiest way, I guess, to do this problem would be to write it horizontally instead of vertically, so something like this. And then to just do what we do when we divide two fractions, which is multiply by the reciprocal of the second fraction. So this problem is just the same as this problem. I just wrote it horizontally. And then I could multiply, I could change it into a product as long as I use the reciprocal of the second fraction. So like this. And then I could simplify. So this actually is a problem that we could have done in the last video I made, which was operations with rational expressions. It is technically a complex fraction because of the fractions within a fraction, but it isn't really much different than just dividing two fractions. So let me go ahead and factor really quickly. I guess I've already factored. I already showed my factoring up above, but I'll show it down here. So x minus 25, x squared minus 25 factors as x plus 5 times the quantity x minus 5. Doesn't really matter what order you write those factors in. Okay, and then I can cross cancel a common factor of x plus 5. And so in the numerator, when I multiply straight across, 2 times x minus 5 is 2 times the quantity x minus 5. And then I just have 6x left in the denominator. And so this would be my answer. Now you're welcome to distribute that 2 if you would like, but it is okay to also leave your answer in factored form. Okay, I've got one more on this video. This one looks like fun. Okay, so I'm going to look at all the denominators, x minus 2, x plus 3, x minus 2, x plus 3. So if I were going to try to make all the denominators the same, then my denominator that I would use would be x minus 2 times the quantity x plus 3. We call that the least common denominator. So I'm going to multiply. I'm back to what I did for number 1. Okay, this one I could not write it out as it's currently written. I couldn't write it out like I did number 2. Okay, but I'm going to multiply both the numerator and the denominator by the least common denominator. And because I'm multiplying both numerator and denominator by the same thing, I'm going to have an equivalent expression. Essentially, I'm just multiplying by the number 1. And so I'm going to have to take this I am going to multiply all terms by this. So I'm going to distribute this to the 3 over x minus 2. I'm going to distribute this to the 4x over x plus 3, and so on and so forth. So let me show here real quick. Actually, first let me use a different color. So when I multiply the numerator by the LCD, I am going to multiply this and this both by my LCD. Same thing here in the denominator. So I'll show that I am distributing. There we go. Okay, now down here I'm going to show my work real quick. So if I take 3 over x minus 2 and I multiply it times our LCD, and just to kind of help us, I'm going to write it over 1. Just feel like that helps to see the cross canceling a little easier. So they both have a factor, both numerator and denominator have a common factor of x minus 2. I can cancel that. And so it looks like I have 3 as well as x plus 3 left. So I've got 3 times the quantity x plus 3. All right, plus, okay, so I'm also going to take my LCD times 4x over x plus 3. So let's show that. So we've got 4x over x plus 3. I'm going to multiply that times x minus 2 times the quantity x plus 3. I'm going to write it over 1 just to help us to see the cross canceling. I do have a common factor of x plus 3. So it looks like I have 4x times the quantity x minus 2. Okay, so that was just the numerator. We're going to do the same thing here in the denominator. Instead of showing all this work, I'll just kind of do it kind of quickly, but I'll explain what I'm doing. When I multiply this LCD times x over x minus 2, x minus 2 would cancel with x minus 2. I'd be left with x times the quantity x plus 3. And then finally, 5 over x plus 3 times our LCD. The x plus 3 here in this denominator will cancel with this x plus 3. I'll be left with 5 times the quantity x minus 2. Okay, guys, that was the hard part. From here, so this is just kind of my extra work over here. From here, we just distribute and combine like terms. So we're almost done. In the numerator, I'm going to have 3x plus 9 plus 4x squared minus 8x. In the denominator, I'm going to have x squared plus 3x plus 5x minus 10. And then, like I said, we'll just combine our like terms. In the numerator, 4x squared does not have a like term. I can combine the 3x minus 8x. That would be a negative 5x. And then plus 9. And then in the denominator, x squared plus, it looks like those middle terms are like terms, and then minus 10. All right, and then technically we should double check that these do not factor. I know they don't because I made up this problem. But anyway, you could check like down here in the denominator, for example, if this would factor, then that would mean there'd be two numbers that add to 8 and multiply to negative 10. But there are no two numbers that add to 8 and multiply to negative 10. So the denominator doesn't factor. And if the denominator doesn't factor, then we know the whole thing can't be simplified. Even if the numerator could factor, if the denominator doesn't factor, then there's no way we're going to be able to cancel any common factors. So we're done. That would be our final answer. Well, thanks for watching, guys. I hope you have a better understanding of complex rational expressions.